Going to demonstrate my complete VoIP lab setup using two Cisco routers running Call Manage Express and two Cisco IP communicator phones. Before I configure in VoIP, I first prepare all of my virtual machine, make sure the network is correct so everything can communicate properly. At the beginning of the video, I am setting up both my Windows VM, all of my VM using the host only network in the VirtualBox. This keeps everything isolated inside my lab and gives me a full control over my IP range. I assign each VM an IP address, subnet mask, and default gateway and DNS. This is very important because my PC's routers and phone must be on the same network. I also disable the Windows firewall so nothing block TFTP or phone registration. I enable an audio on the CAPCs of phones so they can play ringtones and voice. After the installation of Windows VM, I'm installing the Linux virtual machines that will run the Dynamics and which emulate my two Cisco routers R1 and R2. After setting up the networks, I also install two important Linux packages, bridge utilities and UML utilities. I install these utilities because they give Linux the ability to create bridge interfaces and tap interfaces. These are required because Dynamics required use the tap interface to connect the virtual network. Next, I configure the Linux network by editing the configuration file inside the folder etc network interface. This is where a Ubuntu stores additional network interface files. In this file, I create a Linux bridge. A bridge works like a virtual switch. I attach the physical adapter to the bridge so my virtual routes can connect to the same networks as the Windows PCs and the phone. After editing, I restart the Linux network service so the bridge can take effect. Now I install required development tools that allow me to build Dynamics from the source. Then I download the Dynamics source code and compile it. This process creates the actual emulator that will run the Cisco iOS images. When I compilation finish, I install the final Dynamics program and create a shortcut so I can launch it from anywhere. Now, the next I create a script for router 1. This script does three main things. It creates a tap interface and it connects the tap interface to the Linux bridge bureau, and it launches the router using Cisco IS images. After this script, I give the script permission to run and connect to the router using telnet on port 2521, and I configured the router and put a host name as a R1. After I create router 1, then I create the script for R2 by copying from the first script of R1 and changing the tap interfaces to 2 and the telnet port to 2522. Both the routers are now running inside the Linux and connected to the same host only network as the Windows machine. Before configuring the routers, I would like to explain the VoIP basics. VoIP stands for Voice over IP. It sends voice traffic over the same network and used for data. Instead of old phone lines, voice is converted into packets. To build a working VoIP system, we need a proper IP addressing, routing, a phone server. In my case, we used CME in this lab. IP phones like CAPCs and reliable network connectivity. If any of these pieces are missing, phones cannot register and calls will not work. CME or Call Manager Express is built into the Cisco router. It is perfect for small offices, small businesses or lab environments because it is simple and doesn't require a separate server. However, it is not ideal for a large enterprises with hundreds or thousands of phones, but for a small two router lab like mine, CME is exactly what I need. When I configure CME, every step has its own purposes. The IP source addresses tell the phones which router to register with. ePhone DNS create the internal phone extensions. ePhone represent the actual phone. The button command links the phone to its extension. Dial PS define how calls move between routers. All of this combined create a working phone system. Now I configure router 1. R1 uses IP address of 192.168.5.56 2, and based on my student ID, its extension is 7852. I configure the router, clock, DNS server, gateway, and NTP. Then I configure the interface with correct IP addresses. After inside the telephony service, I set the maximum number of phones and extension. I also set the IP source address so CAPC know where it downloads its configuration file. After registering the phone, I created the directory number 7852 and assign it to a button 2 of phone 1, and that matches the lab requirement 1 DN per phone on button 2 by assigning the correct MAC address of the CAPC. And after that I restart the phone, and I made sure that my Windows TFTP server is working by changing my TFTP server IP address, changing into the router's IP so that the phone can download its config. Now let's configure R2. R2 uses the IP address 192.168.563 and its extension is 5952. I repeat the same configuration and steps for R2, clock, DNS, gateway, interface IP, and telephony service. And on R2, after registering the phone, then I create an extension of 7952 and assign it to the button 2 of phone on R2, and also confirm that TFTP is running so this phone can get its configuration file by changing the TFTP IP on CAPC2 and changing it to R2's IP. Here, and next I create a network script. This script brings up both the tap interfaces and attach them to the Linux bridge every time the Linux virtual machine starts. This makes the routers automatically connect to the networks after the reboot. After I configure the script, I run it, and I tried both the tap interfaces are up by using the show commands. Then I restarted both the phone, wait them to register. After now you can see now the phones are registering, and then I also try to ping the CAPs to the router after it's working. So and the phone also got registered. After both the phone register, I tried calling, but the calls fails, and I think this is because the routers don't know yet where to send calls. So I add dial pairs on both the routers. We configured the LP on R1, so we've set the destination pattern as 79 dot can be anything between 0 to 9, and it sends call to R2, and we set a codec and is used for high quality audio. And also we did the same for R2 as well, and we set the destination pattern in R2 as 7978 and it sends call to R1 at 192.168.562, and we set the codec as well on R2 as well, and we restarted both the phones. After that we tested the call by calling each phones. Both phones ring, both phones register correctly, and audio works as you can see. Thank you.